In this lesson, we'll solve radical and absolute value equations. Let's start with radical equations like this one here. Radical meaning there's a root in it. This one is the square root of x plus 1 is equal to 5. The strategy is to isolate the root portion and then square both sides of your equation in this case. So I'm going to start by subtracting 1 from both sides. That leaves us with the square root of x is equal to 4. And if you want to get x by itself, to undo a square root, you can square both sides. So I'll square the left and the right. If you square the square root, they cancel, and it leaves you with x, and 4 squared is equal to 16, and this is the possible solution to the original equation. So let's just check to see if this works. Is the square root of 16 then plus 1 equal to 5? Like, is this true? Well, the square root of 16 is 4. And okay, 4 plus 1 definitely equals 5. So yeah, this worked. So this outlines the general strategy for dealing with a square root. In this case, square both sides. So let's try this method on a slightly more complicated equation. This one is the square root of 8 minus 2x is equal to x. Because we have a square root, I know squaring it will cancel. So I'll square the left, but I gotta make sure I do the same thing to the right. Okay, on the left, if you're squaring the square root, it leaves the 8 minus 2x by itself. So we get 8 minus 2x. And x squared, well, that's just x squared. So this is the new equation that we'd like to solve. And I'm seeing that it's a quadratic. What I'm going to do is add 2x and subtract 8, so this side is equal to 0. So what I'm doing is, and we could do this all in one step, I'm going to subtract 8 from both sides, and I'm also going to add 2x. What we get is, on the left, 0. On the right, we have x squared. I'll put the 2x first, and then the minus 8 second. This thing. To solve this type of quadratic, you could maybe factor, maybe you could use the quadratic formula. I think I'm going to try to factor. Okay, I'd have to have an x and an x. Okay, the last number is negative. Therefore, I know I need a positive and a negative. I need two numbers that multiply to a negative 8 and add to a positive 2. Okay, just thinking about that a little bit, I believe it's going to be a positive 4 and a negative 2. The product is negative 8. The sum is positive 2. To get the solutions, I will take both factors and set them equal to 0. And I'll subtract 4 from this one, but I'll add 2 to both sides on this one. And this gives me my two solutions. X is equal to negative 4, and x is equal to positive 2. Now, I want to check to see that these both work. It is possible that in this process, you might introduce something that is actually not a solution to the original equation. So we got to be careful. Do these both work? I'm going to check negative 4. So let's do that. Is x equals negative 4 a solution? I don't think it's going to work. Here's why. The square root of 8 minus 2 times negative 4, is that equal to, well, negative 4? There is no way a square root of anything can yield a negative number. I mean, at this point, I know it's not going to work. But just to simplify it a little bit further to see what's going on here, we have the square root of 8, that's going to be plus 8. Is that equal to negative 4? That's the square root of 16 is equal to negative 4, and positive 4 does not equal negative 4. And what that tells us is that is not a solution. It did not work. But we also have to check 2. Maybe 2 doesn't work. Maybe it does. So I'll check 2. Let's see. That is the square root of 8 minus 2 times 2. Is that equal to 2? That's the square root of 8 minus 4. I mean, this looks pretty good. 8 minus 4 is 4, and the square root of 4 is positive 2. Okay, so that's good. This is, in fact, a solution. In fact, it's the only solution to this original equation. This one, I mean, it looked like it was going to be a solution, but when I checked it, unfortunately, the left and the right side were not equal. Okay, let's try this again. So here I have the square root of x plus 13 is equal to x minus 7. So since we're dealing with a square root, I'm looking to square both sides of the equation. And the reason for this is, if you square the entire left side, you're squaring that entire square root. It leaves us with x plus 13. And on the right side, well, we have x minus 7 squared. Now, what is x minus 7 squared? We gotta be careful here. It's not x squared plus 49. And the reason for that is x minus 7 squared means x minus 7 times x minus 7. So we actually have to distribute x and negative 7 to multiply this thing out. So on the left, we have x plus 13. On the right, x times x is x squared. X multiplied to negative 7 is negative 7x. So I multiplied the x to both terms. Now I'm going to multiply in the negative 7. We get a second negative 7x, but then plus 49. So when all is said and done, the left is still x plus 13, but the right side is x squared minus 14x plus 49. Okay, I think what I'm going to do is, in one step, I want one side to be equal to 0. So I could either factor or maybe use the quadratic formula. So I'm going to subtract x from both sides as well as subtract 13. On the left, we get 0, which is great. On the right, we have x squared minus 15x, and then plus, okay, that's going to be 36. Does this factor? If it does, you'd have to have an x and an x. Okay, they both have to be negative, and the reason for that is the last number is positive. A negative times a negative is a positive. But if you add two negative numbers, you would get a negative number in the middle, so that's good. Okay, two numbers that multiply to positive 36 yet add to a negative 15 are, 12 and 3. The sum is 15, and the product is positive 36. Okay, I'll set both factors equal to 0. I know if I add 12 and 3, these equations become x is equal to positive 12 and x is equal to positive 3. Now, are those both solutions to the original equation? So again, that original equation was the square root of x plus 13 equals x minus 7. It's possible that both could work, or maybe neither work, or only one works. Let's check 3. I picked that one first just because I don't think that's going to work. So here's why. We get the square root of 3 plus 13 is equal to 3 minus 7. And I see on the right side we're going to get a negative number, and there's no way the square root is going to be something negative. Like, we could stop this process, but just to take it a little further, the left is the square root of 16 is equal to negative 4. Yeah, this isn't going to work. 4 is not equal to negative 4. That's no good. So this is actually not a solution. It's what is known as an extraneous solution. Okay, well, what about x is equal to 12? Maybe that works. Okay, that's the square root of 12 plus 13. Is that equal to 12 minus 7? Okay, this looks good. On the left, we get the square root of 25. On the right, we get 5, and, 5 is equal to 5. So this is good. 12 is a solution, 3 is not, and that's it for this problem. Up to this point, each radical equation was a square root, so we had this symbol, like the square root of x. And for emphasis, you can put this 2 here to indicate that you're talking about a square root. What this means as an exponent is x to the 1/2 power. So like if you had a cube root or a fifth root, as an exponent, it would be 1/3 or 1/5. In general, as a definition, if you have an nth root of something to the power of m, as a fraction, this means m divided by n in the exponent. And this is sometimes remembered as it's the power divided by the root. Here in example 3, this is a radical equation, even though I don't see this symbol, this root symbol in here, and that's because we have an exponent that is a fraction. If I was to convert this thing from this to this notation, the equation would look as follows. It is the square root of x minus 4 cubed, and this is equal to 125. So to solve it, we can use a very similar method where, well, I want to cancel the square root. So what you can do is square both sides. And when you do, the left side, it's not just x minus 4, but it leaves you with x minus 4 cubed. So this squaring only canceled this square root. And on the other side of the equation, we could square this out. That's going to be a pretty big value, but I'll write it down. That's 125 squared. That's 15,625. Now, you're solving for x, and I see this exponent of 3 that you want to get rid of. To get rid of this exponent of 3, you can take the cube root of both sides of the equation. It's not the square root, but the cube root. Taking the cube root of something cubed cancels to give you the x minus 4. We don't need the parentheses anymore, so I won't write them. And on the other side of the equation, that's the cube root of 15,625. So I'm going to get that value from my calculator. So if I take the cube root of that number, I get 25. To get x by itself, I will add 4 to both sides of the equation, and we get that x is equal to 29. I'll leave it to you to check that this is a solution to the equation, but if you plug in 29 and simplify this side, it will equal 125. Now, what about solving an absolute value equation? That is something like this. The absolute value of x is equal to 4. I think it's simple enough for this equation to guess the solutions that make it true. For example, I know if you put 4 in place of x, the absolute value of 4 is equal to 4, and what this means is that x equals 4 is a solution. But also, if you put negative 4 in place of x, the absolute value of negative 4 is also 4, and we get the second solution of negative 4. This means there are 2 solutions to the equation, not just 4, but also negative 4, so 2 values actually work. And even though this question was pretty simple, it shows a method that you can use to solve a much more complicated absolute value equation. That is, take the thing inside the absolute value and set it equal to this side of the equation, but also take the thing inside the absolute value and set it equal to the negative of what appears over here. This will allow you to find 2 solutions to the given equation. So what if we change the previous problem slightly? Instead of the absolute value of x is equal to 4, the absolute value of x minus 3 is equal to 4. The strategy will be, all right, we'll take the thing inside the absolute value and set it equal to 4. This equation must give us a solution to this equation, because what you're saying here is put 4 inside the absolute value, and clearly that will make this thing true. But there is another possibility. It could be that the thing inside the absolute value, which is x minus 3, it could be that thing is equal to negative 4. What this equation is saying is put negative 4 inside the entire absolute value. This will also give us a solution to this equation. What this means is when dealing with an absolute value equation like this, you can actually write down 2 separate equations and it'll give us 2 different solutions. These are both pretty simple to solve. Over here, I will add 3 to both sides, and that gives us that the solution is x is equal to 7. And that makes sense. If you put 7 here, 7 minus 3 is 4, and the absolute value of 4 is 4. Over here, okay, again, you're going to add 3 to both sides of the equation, but we get a different number this time. This time we get x is equal to negative 1. But this works too. If you put negative 1 in place of this x, negative 1 minus 3 is negative 4, and then the absolute value of negative 4 is equal to positive 4. So here's our strategy. To solve this equation, set up 2 new equations to get 2 different solutions. So let's look at one more. I want to solve this equation, 2 times the absolute value of x plus 8, then minus 1 is equal to 15. For this question, ultimately, we want the absolute value part by itself. We can't start by setting up two equations because this thing is not isolated. What we need to do first is get rid of this negative 1 and also this 2 that's in front of the absolute value. So we have a couple of setup steps. First, what I'm going to do is add 1 to both sides of the equation. This changes it to 2 times the absolute value of x plus 8 is equal to 16. The next step is I want this by itself, so I'm going to divide both sides of the equation by 2. When we do this, the 2's over here cancel. It leaves us with the absolute value of x plus 8, and on the right we have 16 over 2, which is, well, it's also 8. Okay, at this point, we can now set up two equations. When does x plus 8 equal 8? And when does x plus 8 equal negative 8? These two equations will give us the two solutions to this equation up here. In both of them, we're going to subtract 8 from both sides. And the result is that over here, x is equal to 0, and also x is equal to negative 16. These are the two solutions to the original equation.